Okay, we will go through the exemplar problems in the class 12 chemistry, chapter 11, alcohols, phenols, and ethers. Okay, now some basic things. See how boiling point is determined for a compound. So if the compound has a intermolecular hydrogen bonding, then the boiling point will be more. If it makes intermolecular hydrogen bonds, more molecular mass means more boiling point. More branching means the boiling point will be less. Say if you take two molecules, the one with a comparable mass, okay, this is 46 and 44 comparable mass. This has more branching than this, so this will have the less boiling point. This is 231, this is 351, okay. So this will have less boiling point due to the branching, okay. So here this makes intermolecular hydrogen bonding. So there is no branching here, but here branching is more, but there is no intermolecular hydrogen bonding in this compound. So these three, mainly these intermolecular hydrogen bonding, molecular mass and branching determines the boiling point of the compound. So now how do you determine the acidity? So acidity is nothing but if a compound donates a proton, then it is a acid. This is brown side acid, means it donates a proton to a strong base. This is a base, this is a acid, this is donating a proton, so it is forming the conjugate acid and the conjugate base. Okay, this is strong conjugate base from the acid. So when the electron donating group is attached to a compound, then it decreases the acidic strength. Okay, here one electron donating group, here 2 3, so more electron donating group, then acidity decreases. Okay, more electron donating group means that instability increases, acidity decreases. This is more stable among the compound, this is more acidic, okay, than these things. So electron donation decreases if we compare this phenoxide ion, that is if you remove the hydrogen atom, then the O is connected to the benzene phenoxide ion, then it is alkoxide ion. These two ions, this doesn't have a resonance, okay, but this phenoxide have a resonance. This is more stable, this is more acidic than this alkoxide, okay, this compound, alkyl compounds. Okay, phenol compound is more acidic than alkyl alcohols. Is resonance. In terms of solubility, if a compound makes hydrogen bonding with the water, then solubility will be more. Okay, alcohols and phenol, they form hydrogen bonding in the water, so solubility is there due to hydrogen bonding. Solubility decreases with increase in number of alkyl and aryl groups. So if the more alkyl aryl groups are there here, then solubility will decreases. Monochlorination of the toluene in sunlight followed by the hydrolysis with aqueous NaOH yields. Okay. Yields. So this is toluene. So this after chlorination we have benzyl chloride, then with the NaOH we have benzyl alcohol. So benzyl alcohol. How many alcohols with the molecular mass of this are the chiral in nature? Chiral means four different groups are atom attached to a carbon atom. Okay, that is the chiral carbon. See, if you take these, see these here two similar groups. So this is not a chiral carbon. So here hydrogen, two hydrogen, same carbon. This is here you see one hydrogen, one OH, one CH3. This is the chiral carbon. Okay, so the carbon 12 is the chiral. This is carbon. So the number of how many are chiral in nature? So only one. What is the correct order of the reactivity alcohols in the following reaction? Okay, this is the hydrogen halide. This is the reactivity is more in the tertiary alcohol. Okay, then the secondary and the primary. So this is the reaction. In tertiary alcohol, the derivative is formed immediately is more reactive than the primary. So you can go through it. Okay, this can be given the aldehyde, alcohol to aldehyde. Treatment with pyridium chlorochromate. See here, this alcohol to aldehyde. In the presence of this PCC. The process of converting alkyl halides into alcohols involves RX alkyl halide alkyl halide into alcohols. The X will be replaced by the OH by nucleophilic substitution. Which of the following compounds are aromatic alcohol? The aromatic alcohol OH is not directly connected to the benzene ring. Okay, here OH these things connect directly, so they are not aromatic alcohol. These two, they are the aromatic alcohols. IUP is the name of the compound. Okay. So this is how the longest chain numbering is done, and the substituent groups OH and Cl. So this OH is having greater priority than the Cl. Okay, in the substituent compounds. Okay, longest chain, the lowest number should be assigned to the functional group. So here to Cl and OH, this have the OH is higher priority, so this should have the lower number. So based on this is 5-chloro. 5-chlorohexene 2-ol. 2-ol means alcohol. Methane, ethane, propane, butane, pentane, hexane. The IUPAC name of the M-quisal is 3-methylphenol 5. So 3-methylphenol, this compound. The IUPAC name of the compound 9. See, this is how numbering is on 1, 2, 3. So 2-methyl 2 methoxy. This is the methoxy group connected to the second carbon atom, propane, methane, ethane, propane. Which of the following species connect the strongest base? So these are all derived from the acids. Okay, this is water. From water, from the alcohol, from phenol. Okay, because this is a base after removing the hydrogen. So the from nitrophenol. So the acidic strength, this nitrophenol is greater than phenol, is greater than the water, that is greater than the alcohol. So this is the weakest acid among these things. This is the weakest acid. So strongest base will be formed from the weakest acid. Okay, weakest acid are as the strongest base. We are asking strongest base. These bases are derived from these acids, and this is the weakest acid among these things. After donating a proton, then it will become the base. So weakest acid will become a strong base. Which of the following can react with the sodium hydroxide, that is a base in water? So the phenol is more acidic than the other this group. So because phenol is more stable, that is more acidic. So this will react with this base. So the aromatic ring in which hydroxyl group is connected is more acidic. This is more acidic than one with the hydroxyl group attached to the alkyl group. So phenol is more acidic than the alkyl. Phenol is less acidic than the nitrophenol because this nitro group is connected, that is electron withdrawing group. See, if you look at this, you will see these Ka values. So nitrophenol has a more value than the phenol here. Okay, because of this electron withdrawing group, this is more acidic than the phenol. Which of the following is more acidic? See, among these compound, so the chloro, this is also electron withdrawing group. Okay, this is more acidic than the phenol other compound. Mark the character of decreasing acidic strength. Decreasing acidic, then the more acidic will come first. So this is more acidic among these two nitro group. So that is in the para position will be more acidic than the meta position. First this, then this, then this, then these are all the electron releasing group. Okay, so more electron releasing means is a less acidic. OH3 electron donating, that is releasing group, NO2 electron withdrawing group. Okay, then position, para position will be more than the meta position. Mark the increasing order of the reactivity with nucleophilic substitution. So here there will be more electron density in the benzene ring. Okay, due to this electron withdrawing nature. So NO2 E electron withdrawing group, that is more than the chlorine. Chlorine is less than the NO2. In terms of electron, more electrons in the benzene ring will repel a nucleophile. Okay, so that means it will be less reactive here. So that is less than this because of this repulsion of a nucleophile. So here no electron on the benzene ring, so this will attract the nucleophile substitution. Arrange the following among increasing order of the boiling point. So this is the combination up to more molecular mass. Then if same molecular mass, primary will have alcohol will have the more boiling point than the secondary alcohol, because the primary alcohol tend to make hydrogen bonding. The boiling point alcohol phenols with increase in the number of carbon atoms. Okay. In alcohol, the boiling point decrease with increase in the branching. Okay, more branching, then will decrease the boiling point. The carbon atom. Okay. This also depends on the intermolecular hydrogen bonding. Okay. Okay, multiple choice questions. Which of the following are used to convert this aldehyde into the alcohol? Okay. Aldehyde to alcohol conversion here. So read is a which of the following reactions will yield phenol? Okay. 1, 2, 3. So this will yield phenol here. Which of the following reactions can be used to oxidize primary alcohol to aldehydes? Primary alcohol to aldehydes. Primary alcohol to aldehydes. Okay. So you can go through this. Phenol can be distinguished from ethanol by the reaction with bromine water 20. Ethanol, alkyl and aryl alcohols. Bromination, know this. Okay. Phenol will form the white precipitate. Which of the following benzylic alcohols? Benzylic alcohols, see here we OH attached to the sp3 hydrogenous carbon atom which is connected to the benzene ring. Okay, here. So this carbon atom OH is attached connected to the benzene ring for the, but here you see this carbon atom is not connected to the benzene ring. So these two are the benzyl alcohols. See, what is the structure and IUPAC name of the glycerol? This one. Glycerol. Structure and IUPAC name. Write the IUPAC name of the following compound. Okay, these are the IUPAC names. Write the IUPAC names of the compound here 24. This one. Name the factor responsible for the soluble alcohols in water. The alcohols, number of ethyl groups and ability to form the hydrogen bonding with the water molecules. solubility alcohols and phenol in water, the ability to form the hydrogen bonding with the water. Okay, this is the hydrogen bonding with the water. The solubility decreases with increasing number of alkyl aryl groups. Okay, number of alkyl groups more means it will increase solubility. Sorry, solubility decreases. Solubility decreases with the increase in the size of the alkyl aryl groups. Alcohol is this is the hydrogen bonding size of the alkyl aryl groups. What is the denatured alcohol? The commercial is made from, okay, this is known as denaturation of the alcohol. Mixing some copper sulfate and pyridine. So it is known as the denaturation of alcohols. Alcohol is made under drinking by mixing some copper sulfate and pyridine. Suggest the reaction for the following reaction. This is alcohol to ketone. Okay, this one. Out of 2-chloroethanol and ethanol, which is more acidic on why? Because this chlorine is there in the ethanol, that is electron withdrawing group. This will be more acidic. Because of this minus A effect. Okay, this is more acidic. Such a conversion of the ethanol alcohol to aldehyde. This is same as this alcohol to aldehyde. Okay, here. Suggest a reagent for the conversion of the ethanol alcohol to the ethanoic acid. 30. Any strong oxidizing agent. Okay, ethanol to ethanoic acid in the presence of the oxidizing agent. Here do not okay, here such as oxidizing agent and elevated temperatures. Okay, this takes place. Okay, this will become ethanoic acid. Out of orthonitrophenol and paranitrophenol, which is more volatile. Orthonitrophenol is steam volatile due to the intramolecular hydrogen bonding, while paranitrophenol is less volatile due to the intermolecular hydrogen bonding. Okay, intramolecular hydrogen bonding and intermolecular hydrogen bonding, which causes the association of the molecules. Out of orthonitrophenol occurs which is more acidic. Orthonitrophenol. This is nitro group which is withdrawing but in the other compound there is a CH group which is electron releasing. So in this we have a CH group which is electron releasing 5. See here we have a CH group here which is electron releasing group. When phenol is treated with bromine water, white precipitate is obtained. Give the structure and name of the compound formed. This is the structure after the bromination of the phenol. Tribromophenol is the name. Okay, tribromophenol. Arrange the following compound in the increasing order of their acidity and give the suitable explanation. Okay, this is more acidic than phenol. Then this is electron donating group is there here. So this is more acidic. So this is more acidic than phenol. Then phenol is more acidic than, because this is a electron donating group. This is having electron withdrawing group. That is more acidic than this. Alcohols react with active metals like sodium, give the alkoxides. Write down the decreasing order of the reactivity of the sodium metal. Okay, 35. Decreasing order of the reactivity of the sodium metal is primary is greater than the decreasing. Okay, primary greater than the secondary and the tertiary. Alkoxide ion. Okay, this is more reactive than this and this. More reactive than secondary than tertiary. What happens when the benzene diazonium chloride is heated with the water? Diazonium are hydrolyzed by the phenol by forming method. Okay, so the annealing diazonium gas, then you will get phenol. Arrange the following compound in the decreasing order of their acidity. Decreasing order. Okay, electronegativity of the oxygen is more than the carbon. Okay, so here the electronegativity of this oxygen will be more than the carbon. 37. H2O is greater than the ROH because water is more acidic than the alcohol. Alcohol is more acidic than the alkene group because of this electronegativity more here. Okay, water is more acidic than the alcohol. Name the enzymes and write down the reactions involved in the preparation of the ethanol from the fermentation. The These are the enzymes. Okay, zyme is inverter. These are the enzymes involved in the fermentation. How the propane to an ketone is converted into this alcohol. Ketone, using Grignard reagent, we are converting into the alcohol. Write down the structure of the isomers of the alcohol in the molecular formula. Okay, it's aptical activity, that is the chiral carbon as the actical activity 40. So if you draw the structure, so this one is a 4 different groups attached to the carbon atom, that is the chiral carbon. So this will have the optical activity. So here we have the same CH3 group. Here also we have CH3, same CH group, but here we have 4 different groups. Explain why the OH group in phenol is more strongly and compared to the OH group in the alcohols, because of due to the resonance. Okay. This is the resonance of the phenol. Okay, due to the resonance, this is more stable. Okay. Examine which hydroxide attached to the aromatic is more acidic than the one attached to the alkyl group. Explain why the nucleophilic substitution reactions are not very common in phenol. Nucleophilic substitution, it will repel actually due to the resonance. More electron in the benzene ring, so benzene ring here due to resonance, so repulse nucleophilic substitution. Repulse nucleophile. Nucleophile is nucleus lovers, that means more electron groups are the nucleophiles. So already more electron is there, so it repels. Nucleophile means electron rich, already electron rich, so but benzene ring also electron rich, that is why it is not common. Preparation of alcohols from alkenes involves electrophilic attack, and they explain the mechanism. So this is the steps, so you can go through this. Electrophile attack on this. Explain why this carbon dioxide is non-polar and otherwise, because of this net dipole moment here. This is a linear molecule. Net dipole moment is 0 here, this direction and this direction, but this is there is a net dipole moment. See here, dipole moment this direction, this is, so it cancel out, but ROR we have structure like this, that is greater than 109 degree due to repulsion. So the net dipole moment in this direction, there is a net dipole moment here. Okay, this dipole moment are the same direction, so the resultant dipole, there is a resultant dipole here, resultant dipole is 0. Why is the reactivity of the all the three classes of alcohols with the concentration HCl and zinc chloride? This HCl plus zinc chloride is a Lucas reagent. Okay, 45. Alga react is a Lucas reagent to give carbocation, carb cation. Carb cation more stable the carb cation is, the faster will be the reaction. Is the reaction more stable, then faster is the reaction. Okay, so you can go through this reaction with the HCl and zinc chloride, Lucas reagent. Phenol to aspirin. This is the phenol. Then anyway, this compound salicylic acid. And then the protonation. Then you will have the aspirin. Nitrogen is an example of the aromatic electrophilic substitution. Okay, and its rate depends on the group already present in the benzene ring. Okay, out of the benzene and phenol, which one is more easily nitrated? Why? Phenol is more easily nitrated than the benzene. The presence of the OH group in phenol increases the electron density in the orthogonal position of the benzene ring due to the plus or effect. Nitrogen being the electrophilic substitution is more fatal where electron density is more. Okay. The hydroxyl phenol is directly attached to sp3 hybrid acid carbon sp2 benzene ring, which acts as the electron withdrawing group. And due to this, the charge distribution of the phenol molecule depicts the resonance structure. Okay. In Gould's reaction, instead of phenol, phenoxide ion is treated with the carbon dioxide. Why? 48. Phenoxide ion is more reactive than the phenol. So phenoxide ion is more reactive than the phenol towards electrophilic aromatic substitution, and hence undergoes electrophilic substitution with the carbon dioxide, which is a weak electrophile. Okay. Phenoxide ion doesn't have that hydrogen. Okay, phenoxide ion more reactive than the phenol. Phenoxide by treating the phenol with the sodium hydroxide is even more reactive than phenol towards electrophilic aromatic substitution. The dipole moment of the phenol is smaller than the methanol. Dipole moment of the phenol is smaller than the methanol. Okay. In phenol, the C double bond O is less polar due to the electron withdrawing effect of the benzene ring with the resonance. Okay. In methanol, the CO bond is more polar due to the electron releasing group. Methanol, this is electron releasing group. So this is more due to this is more polar, but in phenol due to resonance there is less polar. Ethers can be prepared by the Eliason synthesis, in which alkyl halide is reacted with the sodium alkoxide. Can't be prepared by this method. 50. In derivative elimination is favored over the substitution, so alkene is the only reaction product and ether is not formed. Okay. Why is COH bond angle in alcohol is slightly less than the tetrahedral, whereas COC bond the ether is slightly greater? Alcohol and ether bond angles. So here this is due to the repulsion between the unshared electron pairs of the oxygen. Okay, this is in the alcohols slightly less than the tetrahedral angle. Okay, in ethers, okay, 4 electron pairs, that is the DuPont pair and lone pairs of electron in the oxygen are arranged approximately in the tetrahedral arrangement. The bond angle is slightly greater than the tetrahedral due to the repulsion interaction. Okay, between the two these things. Okay, this is alcohol and ether. Explain why the low molecular mass alcohols are soluble in water due to hydrogen bonding. The ability to form the hydrogen bond, solubility decreases with low molecular mass. Okay, the solubility increases due to the hydrogen bond. Explain why the para-nitrophenol is more acidic than the phenol, because it is to the nitro group. And substitute with the presence of the electron withdrawing group, okay, the nitro group, okay, nitro group, the acidic strength of the phenol enhances the acidic strength of the phenol. He explained why the alcohol and ethers are comparable molecular mass must have a different boiling point. Must have a different boiling point. Alcohol and ether due to the presence of the hydrogen bonding in alcohols. Okay, alcohols forms hydrogen bonding. The carbon oxygen bond in phenol is slightly stronger than the methanol. Resonance. This is due to the fact that phenol conjugation of the unsaturated over the oxygen with the aromatic ring results in partial double bond character in the carbon oxygen. See here sp2, here sp3. Methanol it is sp3. So more S character, more electronegative. The bond formed between the oxygen and the sp to hybridized carbon is more stable than the formed between the oxygen and sp3. Okay. Arrange the water, ethanol and phenol in the increasing order of their acidity and give the reason. Water, that is more acidic than the alcohol or ROH. Phenol is more acidic than the water. Water is more acidic than the ethanol. Increasing phenol is more acidic than the water, then water is more acidic than the ethanol. The phenoxide ion obtained after removal of the proton from the phenol is stabilized by the resonance, that is more stable than more acidic. After remove the proton is divided by the okay. But here in this is electron releasing group. Okay. So these are the matches, column 1 and column 2 names. Okay, this is a D. Okay, these are all given in the book. Okay, you can go through this. That is C, this one, uh, this one, G. Match the starting materials for the given column and products. Okay. So you can go through the answers of this. Match the items in the column 1. These things. Assertion and reason. Addition reaction of water in a butane is acidic medium yields butane. This is alkene to alcohol in acidic medium. That is wrong. Addition of water in acidic medium proceeds through the formation of the primary carbocations. Here are wrong. P-nitrophenol is more acidic than phenol. This is correct one. Because of the electron withdrawing group nature. Nitro group helps in stabilization of the phenoxide ion by the disclosed negative charge. Okay, like resonance. Okay, this is correct. IUP is the name of the compound. So this one is wrong. IUPAC nomenclature, ether is regarded as the hydrocarbon derivative in which hydrogen atom is replaced by the O or aryl group, where R is the aryl alkyl. Okay, that is correct. Bond angle in ether is slightly less than. Actually, this is slightly more than. So here less than, that is wrong. It should be slightly more than. There is a repulsion between the two beta. This is correct. Repulsion. This is correct. Boiling points of the alcohol and ethers are both, or they are not both. Only alcohol is more. Okay, so this is why it's wrong. They can form the intermolecular. Both cannot form. Alcohol form the intermolecular hydrogen. So this is also wrong. Like bromination of benzene, bromination of phenol is also carried out in the presence of the Lewis acid. No, that is wrong. Lewis acid polarizes the bromine molecule. Correct. Orthonitrophenol is less soluble in water than the meta and para. That is correct. This is a more active position. M and P nitrophenols exist as associated molecule. This is nothing to related with this session. Ethanol is weaker acid than phenol. That is correct. Sodium ethoxide can be prepared by the reaction of the ethanol. Wrong. Okay. OH group in phenol is orthobride. That is correct. Write the mechanism of the reaction of the hydrogen iodide with methoxybenzene. Okay, this is the reaction. Methoxybenzene hydrogen iodide. X means allied. Okay, so you can go through this reaction, the steps of the reaction. Name the starting material used in the industrial production of the phenol. Industrial production of the phenol. So this is the industrial production of the phenol. Okay, cumene. Write the complete reaction for the bromination of the vinyl, the aqueous non-aqueous medium. Bromination of the phenol. Explained by Lewis acid is not required for the bromination of the phenol. So here in case of phenol, the polarization of the bromine molecule takes place even in the absence of the Lewis acid. Without Lewis acid itself, this polarization takes place. Phenol, the polarization of the bromine. So we don't need the Lewis acid. How can phenol be converted into the aspirin? This is the aspirin, okay. Already there was a answer how we convert phenol to the aspirin. Explain the process in which the biocatalyst is used in the industrial production of the compound known to you. Biocatalyst. These are the enzymes of the biocatalyst. Okay. Enzymase, inverter. These are enzymes that are biocatalyst. Okay.